Thank you for joining us for this Power Ed overview of the Kaiser A420 performance testing system. The A420 hardware software package is a state-of-the-art system developed for research and performance testing. This system is designed to capture accurate force, velocity, power, and acceleration metric points at every position on the strength continuum. The Kaiser A420 system gives the participant and performance specialist the tools to maximize human performance through a specialized software protocol. This technology can be utilized with any of the Kaiser resistance training units. However, we recommend using the Kaiser A300 leg press and the Kaiser A300 chest press for most applications. These machines are the most capable units to test both lower and upper body pushing capabilities. These units also reduce the need for advanced technical proficiency to perform the exercise. In addition, it guarantees that any improvement in kinetic or kinematic variables are completely contributed to a positive adaptation, as opposed to an increase due to an improvement in technical capability. The true advantage of the Kaiser A420 platform is its ability to act in the same manner as an engine dynamometer. Not only can the system track force, velocity, power, and acceleration, this system can track unilateral and bilateral comparisons. These data points can aid in developing baselines that can be used to track improvements over time, in addition to creating return to play and return to perform criteria. The test utilized with the A420 platform is referred to as the 10-rep test. Using a predetermined 1RM, the A420 software automatically determines 10 resistances covering the entire strength continuum in equal proportions. This approach to performance testing now allows coaches and trainers to track real-time improvements anywhere from absolute speed to absolute isometric strength. Once the 10-rep test is completed, the results are instantaneously available for review. The entire testing process takes less than 10 minutes. The A420 platform will then utilize 5 data charts to delineate the data captured. Please join Ty Savan, Kaiser's Director of Human Performance, Education, and Research, as he takes you through an overview of Kaiser's 5 data charts.
The first chart I'd like to review with you today is what we call the variable test chart. This is the chart that we illustrate the force velocity profile that was achieved by taking the 10-rep test through the A420 software platform. We do know that we do have a very high level of reliability in creating these force velocity profiles. This was proven in a study published on February 1st, 2021 by the Norwegian School of Sports Science that concluded the 10-rep test was substantially more reliable in creating these force velocity profiles as compared to a jump squat or a counter movement jump. So as we get started, let's start by turning everything off in the graph and kind of starting from scratch to give a pretty good understanding of what the capabilities of this chart have. Now first, we're going to just start with some data points. These were the actual resistances that the program calculated through the 10-rep test. Now when you enter your estimated 1RM, that becomes your 10th repetition. If you overestimate that 1RM, then you may only get 7, 8, or 9 repetitions. But if you underestimate it, as in this case, the program will add resistances until you decide to stop or you fail at a resistance. So each one of these points on this chart represent a resistance. So let's start with the first resistance, which was 46 kilos, which is roughly 15% of the 300 kilos as the estimated 1RM. And we see that it happens roughly at 1.85 meters per second. And consequently, for each of the resistance, we have a corresponding velocity. Now, this creates, with the use of an algorithm, the force velocity curve that intersects both the vertical and horizontal axis. And through this force velocity curve, we're now able to create 2 main baselines for our left leg. In the case is blue, we're looking at the left leg. Where this force velocity curve intersects the vertical axis, this creates our max velocity baseline. And if we look over here on the right, we see that that happens at 2.16 meters per second. And we also can create a absolute isometric strength baseline, and this is where the force velocity curve intersects the horizontal axis, and that happens at 159 kilograms. And obviously what we can do for the left leg, we can do for the right. So here are the individual data points for the right leg, and then here is the force velocity curve that the computer program creates through its algorithm. And as we can see in this case, the left leg is the stronger leg because it has a max force of 159 versus 158 for the right leg. However, the right leg is what we would call the speed leg. Its max velocity capability intersects that vertical axis at 2.19 meters per second versus 2.16 meters per second. Now that we have these basically four baselines, two for the left and two for the right, we can now put the power into the equation, add the power into the equation. So at each one of these resistances, we have a power output, and here's the power output. If you go over, that's going to correspond to a wattage on the right vertical axis. This would be the left leg, and we can now add the right leg. Again, if we go back, we're able to create this parabolic power curve that corresponds to both the left leg and the right leg. And then now we're able to get our third unilateral baseline, and that's going to be our max power. And the max power for the left leg is 842 watts. And for the right leg, it's 849 watts. And as you can see, the leg that is the fastest is the leg that is able to create more watts, even though it generated less force. So this is a pretty good overview of our summary of the variable test chart. We also have other items here on the right hand side that have to do with slope and whatnot, and that is used in certain situations. But for the most part, this is a good illustration of how to create a unilateral force velocity profile using the Kaiser leg press. Moving on, the next chart I'd like to review is referred to as the BIREP chart. The BIREP chart is used to compare multiple variables of how they unilaterally compare to each other. For example, here we have highlighted left peak power and right peak power. So what we're looking at is we're looking at the peak power that was achieved on rep 1 on the left leg here at 639 and on the right leg at 674. And for each repetition that was performed during the 10 rep test, we have a comparison. What we can simply do is click on the ratio button and it'll do the calculation for us. We'll get rid of the actual power outputs, and we can see on rep 1 we had a 5.3% discrepancy in power output between the left leg and right leg, and we can go through all of the 11 repetitions and we can see that they were all under 6%, which means that this athlete would not raise a red flag for an imbalance. Now we also have the ability to compare average power, we have the ability to compare work, range of motion, and reaction time. And in this case, there looks to be like there's no need to investigate anything farther, but let's now move on and look at a participant who shows a big irregularity between the left leg and right leg. What I've simply done is I've now switched to a participant who has a high irregularity between the left leg and right leg when it comes to peak power. What I'll simply do is again click on the ratio button and I'll click off of the actual power output so we can see. And we can see here on the second rep we have a 13% discrepancy, 10.8. We have a 21.5 right around max power. Now what's really interesting in this case is this participant did 14 reps. Now this participant was cleared from a sports medical perspective to return to play. And typically return to play protocols are based on just your strength capability. And as we can see here on that last repetition, there's not a whole lot of power disparity at very high resistances. But when we get into this power zone here between that 11th rep and that 7th rep, we see that there's really high disparity here. So that's really indicating that this person may be ready to return to play, but probably not return to perform when we have such a high disparity. What I'll quickly do is let's switch back to the variable test chart for this athlete and show you what that variable test chart would look like when we have a high discrepancy between left leg and right leg power output. I wanted to circle back to this variable test chart to be able to illustrate how you can use information from one chart to help figure out the pieces of the puzzle. Well, we identified that this participant had substantially greater than 10% discrepancy at many resistances through the A420 test. So when we come back to the variable test chart, we can start looking at the components of power, which is force and velocity. And as we look at these force velocity profiles, we see that both the right leg and left leg have very similar force capabilities. However, when we look at the velocity aspect of it, we see that the right leg has substantial greater velocity capabilities than the left leg, and that greater velocity leads to an increased power output. So in this situation, knowing that this is an athlete recovering from an injury, we can surmise that they did a very good job working on the strength aspect of the rehab process, but they didn't work really on the neural drive aspect that leads to velocity capabilities. So in this case, we can determine that the power deficiency is probably more linked to the velocity side of the aspect. So this athlete needs to do more elastic reactive speed training and more power training in order to get back to a state of balance. What we're going to review now is called the graph chart, and the graph chart is simply taking all the kinetic and kinematic data and put it in a graphical representation. What we have here is we have every repetition, and we can scroll all the way through, that was captured, and we'll focus in on one, and we'll take it and we'll blow it up a little bit so we can get a better idea. Now what we're looking at here is going to be the red line will be the calculated time that pressure was applied to the pedals through the leg press for the right leg, and the blue line would be the left leg. And then we see the blue square. This will be the position through the range of motion where peak power was achieved for both the left leg and right leg. And what we can simply do is we can look at the curve, the power curve that happened through that range of motion for the left leg, and then we can go for the right leg and look at the power curve. We can also look at the right velocity, and we can look at the left velocity, and so on and so forth. So what we have here is power, force, velocity, position, and acceleration for both the left leg and right leg, and then it'll tell us exactly what the range of motion was by the calculated time and the point at which peak power occurred on the right leg and left leg. What's interesting about this is you'll start to see some disparities between right and left leg of where peak power happens through that range of motion, and again, that can all be correlated back by using the bi-rep graph and by using the variable test chart. The fourth item that we're going to investigate today is called the summary chart. And the summary chart is simply all the numerical data that was captured during the 10-rep test, and that includes metric points for velocity, force, power, and acceleration. So any data mining that needs to be done, if you want to pull any of the values from the 10-rep test, this is an easy way to do it. And we can also get this information transferred into a CSV file that can be easily used with your own program. The fifth and final chart I'd like to review is what we call the force velocity comparison chart. And this chart can be used to compare the same participant over time or multiple participants competing in the same discipline. But let's look at a scenario where we have the participant who had the big unilateral imbalance of power output that we looked at earlier. And if we look at the first test when he was cleared to come back to play, we see this in black. Now in 6-week intervals, the next test he took was the blue test, and we see that we had a little bit diminishing force as more priority was placed on power and speed components. And finally, after 12 weeks, we can see in the orange that we have slightly diminishing force, but we have substantially higher power, and we have increased our max velocity component by over 14%. So this is a good way to determine if the program design is matching up to the adaptation that occurs, or we can also use it in a scenario of where we're trying to create key performance indicators for certain positions of different disciplines. So this is a pretty good overview of our force velocity comparison chart, and I think this can be beneficial for many different circumstances and has a lot of value for a sports performance specialist. On behalf of the entire Kaiser team, I'd like to thank you for taking time to review our presentation today. If If you have any additional questions about the A420 software technology, I highly encourage you to reach out to one of our regional sales members, and we can set up a consultation with a member of the Kaiser education team. Again, we thank you for your time and thank you for the support of the Kaiser Corporation.